Welcome to Problem Solving. This is a video to help students better understand mixture problems. Concepts and examples will be introduced and exercises will be given which you can answer for practice, after which solutions will be presented. But before we continue, it is assumed na you have working knowledge in translating verbal statements to algebraic expressions. Kung nakalimutan nyo na, you might want to recall basic concepts. Don't worry though, we'll still try to explain some previous topics naman as we go along. Soks lang. This video is rather long, so if you are confident enough to skip to other parts of this video, you can click the timestamps in the description below. I would recommend though na watch everything so you can better master this topic. The concept of mixture is important as this has a lot of practical uses in real life. This also lays down the foundation in concepts in chemistry in your later years in high school. But before we do problem solving, however, let us define some terms first so we can better understand concepts. First, solution. A solution is a mixture of two or more substances. Let us look at an example of a mixture, something all of us are very familiar with. Coffee. We know that we need water to have coffee. Then we mix, of course, coffee granules and then add sugar. Well, these are the basic ingredients. Some may add some milk or other stuff to add flavor to the mix. But this resulting mixture of substances produce coffee, an example of a solution. Now, a solution has several parts. The first one is called a solute. It's actually a substance dissolved in another substance to form a solution. Now, going back to our coffee mix here, we actually have two solutes. We dissolved coffee granules and sugar in water. Thus, they are both solutes in this mixture. Problem-solving questions, however, usually focus on only one solute. For example, a salt solution, the one we use for gargling, has salt dissolved in water. A sugar solution, used as a glaze in baking, has sugar dissolved in water. An acid solution, used to sanitize work areas, has pure acid mixed with water. Now, another part is called solvent. It's actually a substance that dissolves a solute to form a solution. From our elementary days, we of course refer to water as the universal solvent, meaning it can dissolve almost anything, well, given enough time. In problem-solving questions that we will encounter, water is usually our solvent. And finally, a very important term, concentration. It's a measure of how much a given substance there is mixed with another substance, and this is usually given in percent. Now, we consider a constant amount of mixture. We have to know that the higher the concentration value, the more solute is present in the mix. The lower concentration value, the less solute is present. Now, to understand these concepts better, let's look at some salt solutions. Let us analyze salt solution A. We do this by organizing our data by placing them in a table. Kunwari, we have 1,000 grams of solution A, which is 40% salt. This solution, of course, is composed of salt and water. Now, what if we're asked, how much pure salt in grams is in the solution? Since we know that the solution is 40% salt, we simply multiply the amount of solution, that is 1,000 grams, by 40% or 0.4 when converted to decimal. We then find out that we have 400 grams of pure salt in the solution. Now, to better understand things, what if we analyze how much pure water is in the mix? One way to get that is subtract 400 grams from the total amount of salt solution, that is 1,000 grams. So, we have 600 grams of pure water. This means then that mixing 400 grams of pure salt and 600 grams of pure water will produce 1,000 grams of salt solution A that is 40% salt. Okay, let's have another example. This time, well, let's say we have 300 grams of salt solution B that is 25% salt. That's the given. Again, to get the amount of pure salt in the mix, we multiply 300 by 0.25, which means there is 75 grams of pure salt. To easily compute the amount of pure water, we subtract 75 grams from the total 300 grams. Thus, we see that there are 225 grams of pure water. This means then that mixing 75 grams of pure salt and 225 grams of pure water will produce 300 grams of salt solution B, that with a salt concentration of 25%. Now, before we go further, it is important to know that when we will use tables later in mixture problem solving, we would be focusing on the solutes. Medyo kakalimutan muna natin yung mga solvent like water. Thus, we might want to get familiar with tables similar to what we have here. Now, usually in mixture problems, we have an original solution, then we add another solution, resulting to a new mixture. And as we said earlier, we focus on the solute in mixture problems. So, let us try to analyze the original solution here. To represent this concept, we can count the number of salt granules here. Notice that there are 6 granules in the original solution. Then, we add a second solution with, let us count, 12 granules of salt. We can conclude then that the resulting solution should have 6 plus 12 equals 18 number of salt granules. Make sense? This now then leads us to the general formula in solving mixture problems with focus on the solutes. The amount of solute in the original solution, that is 6 in this case, plus the amount of solute in the additional solution, 12 in this case, should be equal to the amount of solute in the resulting solution, 18 in this case. Yep, it would help a lot to memorize this formula. Solving mixture problems is better learned if we separate them in different cases. Case A involves diluting solutions. It means adding pure solvent, usually water, to have a lower concentration in the resulting solution. To visualize this, we have an original mixture here with 8 granules of salt. Then we add pure water, which of course contains no salt. Thus, it results to more water in the solution, but with the same number of salt as the original. Now, analyzing the figures, observe the spacing between salt granules. We can see and sort of taste that the salt granules in the original mix are much closer with each other compared to the resulting mix, which has more spaces in between salt granules. Well, we can, as I said, almost taste that the original is more salty than the result. Well, if you know what I mean. Thus, by adding pure water from a high concentration of salt, we can produce a less salty or lower concentration of salt solution. This is what we call diluting solution, and that is case A. Let's answer example number 1. Please follow as I read the problem. You have 25 liters of a 50% soap solution. Now, how many liters of pure water needs to be added to make a 25% salt solution? Now, of course, kailangan natin i-organize ang given, but let's try and visualize first. Now, we know, of course, that we should use GRESA or given representation equation solve and answer to be able to answer this ng mas maayos. Now, let's visualize the problem first. We have originally 25 liters of a 50% salt solution. So we have here this figure. Now, we are to add pure water. So let's visualize that, which makes a 25% salt solution. So the result will be this one. This means Since we are adding pure solvent here, pure water, this is case 1. Now, let's complete the table here. First, we have, of course, 3 columns. The amount of solution to be written in this column. Next, the concentration of soap or the percent soap in this column. And then, amount of pure soap in this column. If you notice, kapareho siya ng inanalyze natin na salt solution earlier in this lecture. Now, of course, we have sort of 3 solutions here. We have the original, additional, and result. That's why we have 3 rows. Now, let's plug in values. Going back to the problem, you have 25 liters of a 50% soap solution. Now, it doesn't say here kung yun yung original, additional, result. Pero since that's the first thing na binanggit, it must be the original. So, plug in values here. Originally, the amount of solution is 25 liters. So, writing here, 25. Now, it was described to have a 50% concentration. So, this 25 liters here is 50% soap. So, let me write here, 50%. Or you can write 0.5 if you want. Now, we continue. How many liters of pure water needs to be added? So, when you say how many, it means gaano karami, we're looking for the amount. Now, the question is it the amount na ina-add or amount na result ang tinatanong? As you can see, how many liters needs to be added. So that means we can set the amount to be added as X, additional amount. Next, to make a 25% soap solution. When you say to make, that means the result. So that means the result is a 25% soap solution. So let me write here, the resulting concentration is 25%. Problem is, wala nang ibang given. Now, here's a tip. Take note, whenever solving a mixture problem, your aim is to complete the first 2 columns. Okay? Once you complete these 2 columns, kaya nang isolve yung problem. Now, how do we do that? Sir, we have missing cells, this one and this one. Now, notice, originally you have 25 liters. Then, you add something. Of course, the result will be the sum of these 2. So that's a trick. You add this to get the result. So combining, we have 25 plus X. That must be the result. Now, you did that here. 50 plus something is equal to 25. Please don't commit that mistake. You only add amounts. 25 plus X is 25 plus X. But concentration, you do not do that. Instead, you analyze. Here, we're looking for the concentration of soap in the additional mixture. Take note, we are adding pure solvent. Do we have soap when we add pure water? This contains no soap. Therefore, we can say it's 0% soap. Now, these 2 columns are complete. This would be easy now from this point on. The reason is, to get the amount of pure soap, just like yung example natin kanina, we simply multiply the amount of solution times the concentration, you get the amount of pure soap. That means it's 25 times 0.5. How about this one? X times 0. Of course, you can write X times 0 or simply write 0. Of course, this should be true kasi yung inad natin contains 0 soap since we added pure water. Last, represent the amount of pure soap. We simply multiply these 2 columns. We have 25 plus X times 0.25. Of course, we know the equation is always it's the amount of soap in the original plus the amount of soap in the additional is equal to the amount of soap in the result. So, substituting the amount of soap in the original is 25 times 0.5 plus the amount of soap in the additional we know is 0. So, let's write that 0 equals the amount of soap in the result, which is this one. So, let me copy. We have 25 plus X times 0.25. Now, this is the working equation which we need to solve. So, multiplying 25 times 0.5 is equal to 12.5. Don't bother to write 0 there. Next, we distribute 0.25 here. 25 times 0.25 is 6.25 plus 0.25x. We want to transpose 6.25 to the other side of the equation. Therefore, this now becomes 12.5. Reverse its sign. It becomes minus 6.25 equals 0.25x. Combining 12.5 minus 6.25, of course, is 6.25. Now, we don't want 0.25 here. You divide both sides by 0.25. It's using the division property. We cancel these, do the arithmetic, it's 25. Now, going back to the question, we're looking for the amount in liters of pure water that needs to be added. Now, going back to the table, saan ba yung hinahanap natin? The amount to be added, it's this one. Therefore, let me write here, amount of pure water to be added, and it's represented by x. However, we already solved for x. It's 25. Don't forget, always write the units. It's in liters. So the answer is 25 liters. We need to add 25 liters of pure water to produce a 25% soap concentration. Now, just to check, let's see, tama ba na magiging equal ang kanilang soap content at the end? Let's see. Checking, we now have 25 times 0.5 is actually 12.5. So originally, there are 12.5 liters in the original solution. And then, of course, we added 0 soap, so it's useless. And then, solving, we have 25 plus x, of course, here is 25 times 0.25. So 25 plus 25 is 50 times 0.25. It's 12.5 liters. So 12.5 liters of pure soap in the original. Dinagdagan mo ng water, walang naidagdag, resulting to the same amount, 12.5 liters of soap. Our answer must be correct because these are the same. Bring out your notebook and answer this exercise. As in the previous problems, try to solve this step by step to better show your solution. You can pause this video now and solve. Kaya yan! Go! Here's the answer with solutions. Did you get this? You can pause this video to check your answer. Here is another exercise. A little different this time. Kaya yan! Go! Here's the answer with solutions. Did you get this? You can pause this video to check your answer. If case A involves lowering concentrations, case B involves increasing concentrations. This usually involves adding pure solute to have a higher concentration in the resulting solution. To visualize this, we have an original mixture here with, let us count, 8 granules of salt. Then, we add pure salt, which of course contains 100% salt. Again, to demonstrate this, we can count that we are adding 10 granules of salt. Thus, it results to the same water in the solution, but with 8 from the original plus 10 added is equal to 18 number of salt granules in the result. Now, analyzing the figures, observe the spacing between salt granules. We can see that the salt granules in the original mix are less closer with each other compared to the resulting mix with more salt granules cramped, mas dikit-dikit, in the same space. Well, we can almost taste that the result is more salty than the original, if you know what I mean. Thus, by adding pure salt from a low concentration of salt, we can produce a more salty or higher concentration of salt solution. This is case B, increasing concentration. Let's answer example number 2. Please follow as I read the problem. To increase the sugar concentration of a solution from 15% to 40%. So, tumaas ang concentration galing sa 15% originally to 40% final concentration. Now, the question is, how many ounces, that's in OZ, of pure sugar must be added to 80 ounce of the 15% solution? Now, of course, we should be guided by GRESA, given representation, equation, solve, and answer, so that we can be better equipped to solve the problem. Let's visualize it first. According to the problem, we try to increase the sugar concentration of a solution from 15% to 40%. So let me try first and draw the original solution here. Now, we add something. According to the problem, we add pure sugar. So we represent that here. We add pure sugar. And then, of course, we have the result. Now, let's organize the given by filling out our table here. The first column is the amount of solution, and that is measured in ounces or OZ. Now, the second column is always the concentration. In this case, our solute is the sugar. And of course, the last column is the amount of pure sugar. We know, of course, from our previous examples, that to be able to solve this, we have to fill out these first two columns. The moment that we fill this out, we multiply the first and second columns to get the third column, and that would be very easy from there. Okay, let's plug in values then. Again, going back to the problem. To increase the sugar concentration from 15% to 40%, obviously we're talking about concentrations here. So, according to this, originally it was 15% and then converted to 40%. Now, let's put those values here. Originally, it was 15%. And then, it was converted to 40%. So, the result is 40%. Check it. From 15% originally, we added something, and the result is 40% concentration. We continue. Now, how many ounces of pure sugar must be added? So, how many means amount. How many ounces of pure sugar must be added? So that means we're looking for the amount in ounces that must be added. So where do we find that? It's the amount, the first column, to be added. Therefore, this can be our variable x. We continue. To be added to, we add this to the original, of course. The original daw is 80 ounces. That's the amount, 80 ounces of the 15% sugar solution. So, again, just like our previous example, we are missing some cells. This cell and this one. The moment we complete this, this will be very easy na. So, let's analyze. First, we have originally 80 ounces. Of course, we added an amount, an unknown amount, equal to x. Therefore, the result would then be the sum, 80 plus x. Representation of the result amount done. How about the concentration of the mixture that we add? Take note, we added pure sugar. So if it's pure sugar, it must be 100% sugar. Okay, now the two columns are done. Therefore, we simply multiply the first and second. So we have 80 times 0.15. And then x times, be careful here, kanina, the first case, it's very easy. Because we added pure water, it's 0% solute. Since this is pure sugar, it's 100% sugar. And when you convert this, it should be 1. It's not 100, it's 1. That's a common mistake. Be careful with that. And then finally, we multiply these two columns. We have 80 plus x times 0.4. And then, of course, our equation will be the amount of sugar in the original plus the amount of sugar in the additional should be the amount of sugar in the result. Substituting, what's the amount of sugar in the original? You know what? Practically, we're using the third column. Always in a mixture problem, the third column would be our equation. Substituting the amount of sugar in the original, we have 80 times 0.15 plus the amount of sugar in the additional, which is this one. It's x times 1 equals the amount of sugar in the result, this one. Therefore, we have 80 plus x times 0.4. Okay, multiplying, what is 80 times 0.15? It's 12 plus x, 1 times x, equals, we should distribute 4. 80 times 0.4 is 32 plus x times 0.4 is 0.4x. Now, we want all the variables to the left. So we have x, we transpose 0.4, which is minus 0.4x. Don't forget, x has a numerical coefficient equal to 1. All the x's are already on the left. All the constants to the right, we have 32 plus 12 will now become minus 12. Reverse their signs. Now, simplifying, what is 1x minus 0.4x is 0.6x. 32 minus 12 is, of course, 20. We don't want 0.6 there, so divide this by 0.6. You divide this by 0.6. X then is equal to 33.33. That's non-terminating. Okay, now, what are we looking for? We're looking for the amount of pure sugar that must be added, which is represented by x, which is this one. So let me label the amount of pure sugar will then be equal to x. And of course, it should have the unit, and the unit is ounces. So the answer is 33.33 ounces. Now, of course, we want to check whether answer is correct or not. Let's compute the amount of pure sugar here. 80 times 0.15 is equal to 12. And then x times 1. X is 33.33 times 1 is, of course, 33.33. And that's non-terminating. Finally, we have 80 plus 33.33. It's 113.33 times 0.4, which is equal to 45.33. Now, adding these two, 12 plus 33.33 is 45.33. Both are in ounces. Ounces, they are equal. Therefore, the answer must be correct. We need to add 33.33 ounces of pure sugar. Time to answer this exercise. As in the previous problems, try to solve this step by step to better show your solution. You can pause this video now and solve. Kaya yan! Go! Here's the answer with solutions. Did you get this? You can pause this video to check your answer. Here is another exercise. A little different this time. Kaya yan! Go! Here is the answer with solutions. Did you get this? You can pause this video again to check your answer. Case C involves a mixture plus another mixture. Wala nang pure na idinadagdag. To visualize this, we can count granules of salt. We have an original mixture here with, let's count, 6 granules. Then we add a second mixture, hindi na pure ito, but a mixture with water plus 12 granules of salt. Thus, it results to more water in the resulting solution and, of course, with more salt. In the resulting mix, we have 6 granules in the original plus 12 in the additional, resulting to 18 number of salt granules. In this third case, we have a resulting concentration that is between the two mixtures. a more diluted mixture compared to one, or a more concentrated mixture compared to the other. This is case C. Let's look at this third example. Please follow as I read the problem. How many liters of a 70% alcohol solution must be added to 50 liters of a 40% alcohol solution to produce a 50% alcohol solution? Now, ang daming given, di ba? So, don't worry. We'll try to analyze this and organize this in a table mamaya. Meanwhile, let's visualize the problem. How many liters of a 70% alcohol solution? So, we have mix 2, which we need to add. Let's put mix 2 here. Added to an original mix, which is 50 liters of a 40% alcohol solution. It's here. Now, to produce, therefore, the result is a 50% alcohol solution, as we can see here. Now, let's organize the given. Plug in values. Again, we have the first column is the amount of solution, that's in liters, concentration of alcohol in the second column, and the amount of pure alcohol in the last column. Again, of course, we know this will be easy if we have the values of these first two columns. Why? The reason is we multiply the first column by the second column, we get the amount of pure alcohol, just like what we did earlier in the lecture. Plug in values. Mix 1. How many liters of a 70% alcohol solution must be added? We're looking for the amount that we need to add. Let this be X. So, how many liters? That's the question. Of a 70% alcohol solution, let's plug it here. It was described as 70% alcohol. So, how many liters of this should we add to an original? Adding to an original mixture of 50 liters, 40%. So, let's write here. Originally, we have 50 liters of mix 1. And that was described to have a 40% alcohol content. And continuing, to produce, according to the problem, to produce means that's the result. The result is a 50% alcohol solution. Now, don't worry here. Sir, hindi ba dapat 40 plus 70 should be equal to 120? Walang ganun, Mars. Dito lang po ang i-add. This concentration, you don't add. You only add amounts. So, representing, we have 50 plus X. Therefore, we represent the result as 50 plus X. The first two columns are complete. Therefore, we can finally write the third column by multiplying the first and second. We have 50 times 0.4. And then X times 0.7. And then, of course, we have the quantity 50 plus X times 0.5. Now, the ever-important equation. Of course, it's always the amount of solute in mix 1 plus the amount of solute, that's alcohol, in mix 2 should be equal to the amount of alcohol in the result. Substituting the values, practically, the third column lang yan. So, amount of alcohol in mixture 1, we have this one. Let me copy. 50 times 0.4 plus we have the amount of alcohol in mix 2, which is this one. We write X times 0.7. The result should be the last cell there. We have 50 plus X times 0.5. Simplifying, we have 50 times 0.4 is, of course, 20 plus 0.7x equals, distribute 0.5 here. We now have 50 times 0.5 is 25 plus 0.5x. We want all variables to the left. So we have 0.7x transpose 0.5x. So this will come minus 0.5x equals 25 stays here, same sign. Transpose 20. This will now become reverse 20 minus 20. On the right side, we have 5, and on the left side, we have 0.2x. Dividing both sides by 0.2, divide both sides by 0.2, we have x is equal to 25. Now, going back to the problem, we're looking for the number of liters to be added. How many liters to be added? Which is this one. So, the amount to be added, which is x. So, let me write here, amount to be added. It's represented by x, which is already our value here. Don't forget the units. It should be in liters. So we need to add 25 liters of the 70% alcohol solution to produce an alcohol from 40% magiging 50% alcohol solution. Of course, we can always check our answer. So doing that, we have 50 times 0.4. Now this is equal to 20 liters. That's the amount of pure alcohol in mix 1. In mix 2, we have x, which is 25, times 0.7, which is 17.5 liters. Finally, we have 50 plus x, 50 plus 25 is 75 liters times 0.5. Multiplying, this is equal to 37.5 liters. As you can see, if you get the sum of this one, it's also equal to 37.5 liters. They are equal, therefore, our answer must be correct. Time to answer this exercise. As in the previous problems, try to solve this step by step to better show your solution. You can pause this video now and solve. Kaya yan! Go! Here is the answer with solutions. Nakuha ba? You can pause this video to check your answer. Here is another exercise. A little different this time. Kaya yan! Pause mo ito. Go! Here's the answer with solutions. Did you get this? You can pause this video to check your answer. I hope you learned a lot. I'll see you sa next video. Please don't forget to like and subscribe. Happy solving!